In Python, functions are blocks of reusable code. They perform specific tasks. These tasks can range from simple operations like adding two numbers to more complex ones, such as processing user input or interacting with a database. By using functions, we can write code once and reuse it multiple times, which saves time and effort. Functions help us break down our programs into smaller, more manageable parts. This modular approach allows different team members to work on separate functions simultaneously, enhancing collaboration and speeding up the development process. Each function can be tested individually, ensuring that the overall program is robust and free of errors. This makes our code more organized and easier to read. Clean and well-structured code is crucial for maintaining and updating software. When functions are clearly defined and named, other developers can quickly understand their purpose and how they fit into the larger program. This readability is especially important in large projects where multiple developers are involved. Think of functions like recipes. Just as a recipe provides a step-by-step guide to creating a dish, a function provides a set of instructions to perform a specific task. Each step in a recipe is like a line of code in a function, contributing to the final outcome. They have a set of instructions that produce a specific result. For instance, a recipe for baking a cake will guide you through mixing ingredients, baking, and decorating, resulting in a delicious cake. Similarly, a function will guide the computer through a series of steps to achieve a desired outcome. For example, a function called might take a user's name as input. This input is like an ingredient in our recipe. The function will then use this input to perform its task. It might take a user's name as input and process it. It then prints a greeting message. This message could be something like, "Hello John," if the user's name is John. The function encapsulates the logic for creating this greeting, making it easy to reuse whenever we need to greet a user. This encapsulates the greeting logic in one place. By keeping related code together, we make our programs easier to understand and maintain. If we need to change how we greet users, we only need to update the function, rather than searching through the entire codebase. We can then call this function whenever we need to greet a user. This is like reusing a recipe whenever we want to bake a cake. We don't need to remember all the steps, we just follow the recipe. This promotes code reusability and reduces redundancy. By reusing functions, we avoid writing the same code multiple times, which makes our programs more efficient and easier to maintain. Functions are a fundamental concept in programming, and mastering them will greatly enhance your coding skills. We use the keyword in Python to declare our own functions. After comes the function name, followed by parentheses. The parentheses can hold parameters. Parameters are placeholders for the values the function will work with. The function body, indented below the declaration, contains the code to be executed. In this example, is a parameter. When we call Alice is the argument is the actual value passed to the function. Functions can return values back to where they were called. We use the keyword for this. The returned value can be stored in a variable or used directly. This allows functions to perform calculations or operations. They then give us the result to use elsewhere in our code. Here returns the value 15, which is then stored in the variable. We can provide default values for function parameters. We do this by assigning a value to the parameter in the function definition. If we call the function without providing a value for that parameter, it uses the default value. This makes our functions more flexible. They can operate with or without explicit input for certain parameters. In this case, uses the default user. Overrides it with Bob. Keyword arguments allow us to pass arguments to a function using the parameter name. This improves code readability, especially with multiple arguments. It also allows us to pass arguments in any order. This is because Python identifies them by their names, not their positions. We can clearly see that is Whiskers and is cat. The order in the call doesn't matter because we've used keyword arguments. Asterisk, args, and kwargs provide flexibility in handling an arbitrary number of arguments in Python functions. These special symbols allow developers to write functions that can process a varying number of inputs, making the functions more versatile and adaptable to different scenarios. They are especially useful when we don't know in advance how many arguments a function might receive. This is particularly beneficial in situations where the function needs to handle a wide range of input values, or when the exact number of inputs cannot be predetermined. Args, or arbitrary positional arguments, allow a function to accept an arbitrary number of positional arguments. This means that you can pass a variable number of arguments to a function, and they will be accessible within the function as a tuple. These arguments are packed into a tuple within the function. For example, if you define a function with *args, you can call this function with any number of positional arguments and they will be collected into a tuple that you can iterate over or manipulate as needed. Kwargs, or arbitrary keyword arguments, allow a function to accept an arbitrary number of keyword arguments. This is similar to *args, but instead of packing the arguments into a tuple, kwargs packs them into a dictionary. These arguments are packed into a dictionary within the function. This allows you to pass a variable number of named arguments to a function, and they will be accessible within the function as key-value pairs in a dictionary. For instance, if you define a function with **kwargs, you can call this function with any number of keyword arguments, and they will be collected into a dictionary that you can access and manipulate as needed. These techniques are powerful for creating flexible functions that can handle a variety of inputs. By using kwargs, you can design functions that are more general purpose and can adapt to different calling conventions, making your code more reusable and easier to maintain. Additionally, args must appear before **kwargs in the function definition. Understanding how to use kwargs effectively can greatly enhance your ability to write dynamic and flexible Python code. These features are particularly useful in scenarios where you need to write functions that can handle a wide range of input types and quantities. In summary, kwargs are essential tools in a Python programmer's toolkit. They provide the ability to write functions that can accept an arbitrary number of positional and keyword arguments, making your code more adaptable and robust. By mastering these concepts, you can create more flexible and powerful functions that can handle a variety of inputs with ease. Variable scope refers to the region of a program where a variable is accessible. In programming, understanding the concept of variable scope is fundamental. It determines where a variable can be used and where it cannot. This is crucial because it helps in managing the lifecycle of variables and ensures that they are used efficiently within the code. Understanding scope is crucial for preventing naming conflicts and writing maintainable code. When you know the scope of your variables, you can avoid common pitfalls such as accidentally overwriting variables or creating bugs that are hard to trace. This is especially important in large code bases where multiple developers might be working on the same project. Local scope variables declared within a function have local scope. This means that these variables are only accessible within the function they are declared in. They are created when the function starts executing and are destroyed when the function ends. They are only accessible within that function. This encapsulation is beneficial because it prevents variables from being accidentally modified by other parts of the program. It also makes the function more self-contained and easier to understand. This means you can have variables with the same name in different functions, and they won't interfere with each other. For instance, you could have a variable named count in multiple functions, and each count would be independent of the others. This allows for more modular and reusable code. Global scope variables declared outside any function have global scope. These variables are accessible from any part of the program, making them useful for values that need to be shared across multiple functions or modules. They can be accessed from anywhere within the program. However, this also means that they can be modified from anywhere, which can lead to unintended side effects if not managed carefully. However, modifying global variables from within a function requires using the keyword. In many programming languages, you need to explicitly declare that you are modifying a global variable within a function. This is done using a specific keyword such as global in Python. This is generally discouraged to avoid unintended side effects. Modifying global variables can make the code harder to understand and debug. It can also lead to issues where the state of the program is changed in unexpected ways, making it difficult to track down the source of bugs. Always strive to keep variables within the smallest necessary scope. By limiting the scope of variables, you reduce the risk of them being accidentally modified or causing conflicts with other variables. This practice leads to cleaner, more maintainable code. This practice promotes code clarity and reduces the risk of bugs. When variables are kept within a limited scope, it becomes easier to understand the flow of the program and to identify where changes need to be made. This is a key principle of good programming practice and helps in creating robust, reliable software. In Python, you can define a function inside another function. This is called a nested function. A closure is a nested function that remembers and has access to variables from its enclosing scope, even after the outer function has finished executing. In this example is a closure. It remembers the value from the enclosing scope, even after has completed. In Python, functions are first-class citizens. This means they can be treated like any other object, such as variables. We can pass functions as arguments to other functions, return functions from other functions, and assign functions to variables. Here, we pass the function itself as an argument to. This demonstrates the power and flexibility of first-class functions in Python. Functions, with their ability to encapsulate logic, return values, and work with various types of arguments, are essential for writing clean, maintainable, and reusable code. Understanding concepts like scope, closures, and first-class functions further enhances our ability to write modular and efficient Python code. By breaking down our programs into smaller, reusable units, we make our code more organized, easier to debug, and more adaptable to future changes. Embrace the power of functions and these related concepts to elevate your Python programming skills and tackle more complex projects with confidence.